You know that feeling, the alerts won't stop, your clusters are on fire, and the dashboard is screaming words that could only double as horror movie titles. CrashLoopBackoff, ImagePullBackoff, CreateContainerConfigError, and others. Most of us have battled these demons at 3 AM, but here's the twist. They don't have to be nightmares. With the right playbook, you can squash these errors in minutes instead of hours. Let's see what are the most common Kubernetes errors and how to solve them. Let's start with the classic. Your pod keeps restarting like it's stuck in a loop. This error is called CrashLoopBackoff. Your pod is the digital equivalent of a toddler learning to walk. It gets up, falls over, gets up, and falls over again. If you run a kubectl describe pod, you will see a backoff restarting failed container error, which is as helpful as something went wrong somewhere. So to fix the error, we must first check the logs for the real reason. So let's do a kubectl logs crash loop deployment. And we can see in the logs that this is crashing immediately. This doesn't give us too much information, so if you still have no clue, you should try to connect to the container shell and poke around the file system to confirm that the file your code is crying about is actually there. So let's first try to connect to the pod, and we can see we have an internal error. The container was not found. So let's get the deployments to see what is the deployment name. So it's crash loop deployment. And now let's try to describe the deployment to see if we get any information. So we can see in the command that we are actually running an echo crashing immediately, and the exit code is 1, which means that this will always have an error. So in this case, there is a problem with the command. We have to change it in order for this pod to actually work. The next errors I want to talk about are ErrImagePull and ImagePullBackoff. So this usually happens because your cluster cannot pull your container image, so your deployment just sits there doing nothing. The events list usually whispers something like repository name is not known, like it's trying to keep a secret from you. But you have to understand that typos happen, so you should double check your image to see if you don't have any typos. So what we can do is actually describe the pod to see if we get any useful information. So we can see it tries to pull an image that is actually non-existent, so this would be the fix in this case. However, if you're using a private registry, you need to create a secret. So in that secret, for example, if you're using Docker, you should provide a Docker server, the username and the password. And what you need to do is then patch the service account, or basically just add the ImagePull secrets to the pod spec or to the deployment spec in this case. And if you're on a lockdown corporate network, you should SSH directly to a node and try Docker pull manually. And if that fails, that means that you have a problem with the network. The next errors I want to talk about are CreateContainerConfigError and CreateContainerError. Kubernetes just throws up its hands and says, I'm not starting this thing, your spec is broken. This usually happens because you probably added in shiny new config map to your deployment or a new secret, and now suddenly every single pod from that deployment flips to red. When you run a kubectl describe pod, you should look for messages like secret not found or invalid environment variable. Most of the time, it's a typo in the config map name or a camel-cased key that should have been snake-cased. You just need to fix the YAML and redeploy. Another important error is OOMKilled, so you have a memory spike in your application that causes the kernel to kill the process and the pod status flips to OOMKilled or something similar. You have a Java application that quietly creeps up to a 1.2 gigabytes on a 1 gigabyte memory limit, and this usually results in a silent sudden death with no warning. You should check the usage with kubectl top pod to see if you're pinned against the limit you set. Then you basically have two choices, either bump the memory limit in the deployment YAML, or actually fix the application's memory leak by tuning the JVM heap, adding a worker pool, or caching smarter. Another important error is NodeNotReady, so a node goes dark, your scheduler panics, and pods start piling up in a pending state. You SSH into the node, run different commands to just find a solution to what is happening, but you just see an inactive status. If it's a cloud node, just drain and terminate it. Let the auto-scaling group provide you with a fresh, healthy VM. If it's an on-premise server, check the disk space with df-h, and if the varlib kubelet directory is full, free up some space and then restart the kubelet. Failed scheduling is another common error, so your pods are usually stuck in a pending state indefinitely. You see plenty of CPU and memory available if you add it all up, but every individual node is stained like it's allergic to your workload. So in order to solve this, you should run kubectl describe pod and check for events. You'll likely see a message like 0 out of 3 nodes are available, 3 nodes had taint. You can either untaint the node by running kubectl taint node and the node name, or you can add better tolerations to your pod spec so it can be scheduled there. If the issue, however, is resources, like the pod wants 4 CPUs and the biggest node only has 3, you'll have to scale up your node pool, or of course try to reduce the number of CPUs the pod wants. If you're doing Kubernetes right, you will most likely use Readiness and Liveness probes, so you'll also have failures because of them. So your application boots up, but the Readiness probe keeps failing, so Kubernetes never sends any traffic to it. You curl the endpoint on your laptop, it works perfectly fine, but inside the cluster the same check returns a 404. What you need to do is actually check the probe path and port in your deployment YAML. The classic mistake is having the app listen on a port like 3000 while the probe tries to connect to 8080. If your application just has a slow startup time, raise the initial delay seconds value, or even better, add a dedicated startup probe. Another common error is PodInitializing. So your pod is stuck in this state forever. You have an init container that is downloading a 2 GB machine learning model. You have to wait for it to finish. So in order to make sure that everything is okay, you should check the logs of the init container, specifically using the kubectl log commands and specifying the init container at the -c argument. Download to see its progress, and if it seems stalled, exec into the init container and use a tool like NSLOOKUP to check the target. DNS resolution might be broken inside the cluster, but once the init container runs successfully and exits with a code 0, your main application container will actually start. We saw that we need to use multiple kubectl commands like get, describe, logs, edit, and others to try to debug these issues. But there's an easier way in which you can skip half of these terminal commands. A product like Lens Kubernetes IDE can be a massive accelerator. You can see all the pods at a glance, basically by selecting the namespaces that you want, and you can see all of them that have like this yellow triangle have different errors. And if you click on, let's go and do one of them, you can easily attach to the pod, you can easily connect to its shell, you can see the describe command right here and the error summary. In addition to that, you can also get the logs easily by just clicking on it, and at the same time, you can edit the pod. So this can be really helpful. And you can basically repeat the process for how many pods you want, and you can get all the information you require. So we can see in the summary what's happening, we can see the message. It's pretty easy to follow along and try to come up with a solution. But if you want to take it to the next level, you can use Lens Prism. So Lens Prism is an AI assistant inside of Lens, which can be easily leveraged to help you solve these kind of issues. So if I open Lens Prism, I can chat with it and ask it, what's wrong with my pods? Please provide solutions. So you can see that several of my pods are failing to different root causes. I have insufficient resources on some of them, node affinity, ImagePull error, CreateContainerError, CrashLoopBackoff, Liveness, Readiness, probe failures. If I want to get the exact kubectl patch commands, I'll have to let him know which kind of pods I want to fix first. So let's fix one of them. Let's fix the crash loop one. So it tells us the container is running the command crashing immediately with exit 1. The command always exits with code 1, causing CrashLoopBackoff. We should update the deployment to use a valid command, and gives us here a patch solution. Let's go for the ImagePull error now. Let's fix the ImagePull error 1. So it tells us the pod is failing because the image specified cannot be pulled. This could be a typo, missing image, or authentication issues. So it tells us to update the deployment to use a valid accessible image. For example, if you want to use Nginx, we should set the image to Nginx latest. Of course, this is just an example. I can just copy this command and try it out. And it tells me it cannot execute write operations directly. It tells me to copy it and run it in the terminal myself. So let's go to a terminal and run this command. And we can see the deployment has been patched. And in a couple of seconds, we can see it's already running successfully because it could pull the image. Remember, every Kubernetes error has a signature. CrashLoopBackoff means check the logs. ErrImagePull points to registry typo. FailedScheduling is about taints or resources. Try to master these patterns because it will make your life easier when you're using Kubernetes. And if you like this video, don't forget to like, subscribe, and ring the bell to get notified when new videos come up. I'm Flavius. See you the next time.